You are required to check all welding procedures and welder qualifications to ensure they comply with the TWI specification and the particular structure they are being used on. Question number 1. A welding procedure was produced in the form of a single-sided butt weld, 26 mm thick using the MMA process with basic electrode. Which of the following would not be in the approval range from the original procedure? A. Double-side butt, 21 mm thick, MMA process using a basic electrode. B. Single-side butt, 31 mm thick, MMA process using a basic electrode. C. Single-side butt, 32 mm thick, MMA process using a basic electrode. D. Single-side butt, 23, 8 mm thick, MMA process using a basic electrode. The answer is C. Single-side butt, 32 mm thick, MMA process using a basic electrode. Question number 2. A welding procedure was produced in the MAG process using a voltage of 27, amperage of 280 and a travel speed of 320 mm per minute. Which one of the following exceeds the limits of approval range? A. 1.28 kJ per millimeter arc energy. B. 1.68 kJ per millimeter arc energy. C. 1.25 kJ per millimeter arc energy. D. 1.22 kJ arc energy. The answer is B. 1.68 kJ per millimeter arc energy. Number 3. A butt weld 20 mm thick has undergone destructive testing, including impact testing. The structure is intended to operate in temperature below -100 degrees Celsius. The test specimen was welded in the vertical up position using MMA basic electrodes. Which of the following statement is correct, assuming the specimen met the acceptance levels? A. Average energy absorbed 38 joules, PA, PD and PF position qualified. B. Average energy absorbed 32 joules, PA, PB, PC and PF position qualified. C. Average energy absorbed 42 joules, PC and PF position qualified. D. Average energy absorbed 40 joules, PF position qualified. The answer is D. Average energy absorbed 40 joules, PF position qualified. Number 4. Tensile tests were conducted on a 25 mm butt weld with a parent metal UTS of 480 N per square millimeter. Which of the following result would not meet the acceptance level of the TWI specification? A. Failed in parent metal at 452 N per square millimeter. B. Failed in parent metal at 482 N per square millimeter. C. Failed in parent metal at 576 N per square millimeter. D. Failed in weld metal at 600 N per square millimeter. The answer is D. Failed in weld metal at 600 N per square millimeter. You are conducting an audit on consumable at a company premises. This involves the storage, identification and correct usage of all types of consumables. Number 5. You are conducting a sample check on some CMN steel mag welding wire. You notice a consistency in the copper coating. What will this affect? A. Corrosion, ductility properties and level of spatter. B. Wire feed, corrosion, and electrical contact. C. Weld profile, slag inclusion and corrosion. D. Spatter, CTWD and corrosion. The answer is B. Wire feed, corrosion, and electrical contact. You are conducting an audit on consumable at a company premises. This involves the storage, identification and correct usage of all types of consumables. Number 6. During an inspection of MMA electrodes, you notice that some are stored incorrectly. You are required to identify them to ISO 2560. The lettering on the flux coating states E513B. What does the mean? A. Extruded electrode, 510 SI UTS, their welding position, basic coating. B. Covered electrode, 510 N per square millimeter yield, 47 joules at -300 degrees Celsius, basic coating. C. Extrude electrode, 510 N per square millimeter UTS, 30 joules, basic coating. D. Covered electrode, 51,000 SI UTS, 47 joules at -300 degrees Celsius. Hydrogen control to below less than 5 milliliters per 100 grams of weld metal. The answer is B. Covered electrode, 510 N per square millimeter yield, 47 joules at -300 degrees Celsius, basic coating. Number 7. Highly restrained is bent when leaving the contact tip and forms a circle if continuously fed through. Your explanation of this is: A. The bend in the wire is due to the pressure from the feed rollers. B. The manufacturer of the wire designed the wire like this to help improve contact at the welding tip. C. 3 should be a wire straightener in place to prevent this, or the wire will wander, and subsequent lack of fusion could occur. D. The wire is leaving the torch in this manner because the welding hose is excessively bent. The answer is B. The manufacturer of the wire designed the wire like this to help improve contact at the welding tip. You have been requested to be part of a team to visit a plant where numerous large pressure vessels have failed. All the pressure vessels have been designed to operate from low to medium temperatures, manufactured from 50 mm thick A516 grade 60 steel, C equals 0.28%, Mn equals 1.3%, C equals 0.45%, both S and P equals 0.035% max. Some of the vessels have failed on the longitudinal seams, some have failed on the circumference seams, and some have failed on weld attachment. Number 8. A failure has occurred one of the attachments which has been grossly overloaded. The fracture surfaces are rough and torn. A. This would indicate a brittle failure. B. This would indicate a ductile failure. C. This would indicate a fatigue failure. D. All options are incorrect. It would most likely be a combination mode failure. The answer is B. This would indicate a ductile failure. Number 9. One of the fracture surfaces shows a smooth surface followed by a flat rough surface on the fracture faces. This type of failure would have been caused by: A. Cyclic loading follows by operating at low temperatures. B. Gross overloading followed by cyclic loading. C. High temperature operation followed by low temperature operation. D. Static loading, low temperatures, smooth flat surface followed by a reduction in area. The answer is A. Cyclic loading follows by operating at low temperatures. Number 10. The primary mode of failure has been concluded as brittle and the secondary mode of failure ductile. Which set of condition would promote this type of failure, and what appearance would you typically observe on the fracture faces? A. Cyclic loading, low temperatures, smooth surface followed by a flat rough surface. B. High residual stress, low temperatures, flat rough surface followed by torn surface. C. Static loading, low temperature, flat rough surface, followed by a smooth flat surface. D. Static loading, low temperature, smooth flat surface follows the reduction in area. The answer is B. High residual stress, low temperatures, flat rough surface followed by torn surface.